हम में है उजाला अंधियारा मिटाने का, हम में है हौसला नई उमंग बनाने का, हम में है एक जोश हर मंजिल पाने का, हम में है एक जज्बा हर जिंदगी सजाने का,
हम में है जोश हर मंजिल को पाने का, हम में है एक वादा एक सुनहरा कल बनाने का,
हम हैं जिंदगी, हम हैं हर खुशी,
हम है वो रोशनी जो बनाए आपका भविष्य और उज्जवल। हम हैं ONGC।
Worldwide, efforts are on full swing to control the emissions of greenhouse gases and thereby reduce the pressures of accelerated climate change, thereby causing the ecological imbalance. Methane gas is a powerful greenhouse gas due to its shorter residency and higher potency in the atmosphere than carbon dioxide. However, a remarkably clean fuel when burnt, the combustion process of methane produces no particulates and only about half of the carbon dioxide associated with coal combustion. India is having vast coal resources of the order of 248 billion metric tons, which is the 6th largest in the world. India is endowed with huge reserves of bituminous coal of Paleozoic and Tertiary ages within the coal bed methane or the CBM window at depths of nearly 250 to 1200 meters. Government of India awarded 26 blocks to different states, out of which 9 are in possession of ONGC. Out of these 9 blocks, 5 of them are in Jharkhand. These are Jharia Bokaro, North Karanpura, South Karanpura and North Karanpura West, and 1 block each that is in Raniganj in West Bengal, Satpura in Madhya Pradesh, Wardha in Maharashtra and Barmar Sanchor in Gujarat. Jharia and Raniganj CBM blocks were awarded to ONGC Coal India Limited Consortium on nomination basis, whereas other blocks were awarded during the bidding process of CBM Policy 1 and 2. The village Deogada in Jharia CBM block is around 30 kilometers distant from the town Bokaro and almost equidistant from Dhanbad. This is the 6th well and 2nd exploratory well in Jharia block, where ONGC has taken up air drilling operations for coal bed methane extraction project. The air drilling process is the primary step to dig deep into the earth's crust to the coal bed. Then, another set of extraction mechanism takes place for methane extraction. This is basically a brainchild of Mr. Anil Kumar Sachin, the project manager, CBM development project, to introduce it in ONGC. He took the initiative and encouraged a local vendor from Hazaribagh district engaged in water wells drilling to take up the challenge.
We are going today to our new drill site, GHAO. As you see, Jharkhand is a very remote area. For a quite large distance, you don't see any village, any habitation like that. And many times we find very dense forest as well. It's a very hostile terrain, or rather difficult terrain, I should say. That well, it's a hilly area, so movement of heavy equipment and machinery is difficult. We have to make very special arrangements so that everything reaches to the spot, from one spot to other spot very safely, without disturbing any local village or whatever comes on the way. And then security is another major area of concern while working in Jharkhand. We have to see that our people are secured, and we have to provide them a sort of physical security is one part, but we have to make them mentally more strong so that they feel secured that we are taking care of them. Coal mines in this area are very charged with the CBM gas. Many times explosions take place. In the process, miners are killed, and so when the CBM is extracted, mines become virtually more safe to work, and there is no change in quality and quantity of the coal.
हमें है उजाला अंधियारा मिटाने का, हमें है हौसला नई उमंग बनाने का, हमें है एक जोश हर मंजिल पाने का, हमें है एक जज्बा हर जिंदगी सजाने का,
हमें है जोश हर मंजिल को पाने का, हमें है एक वादा एक सुनहरा कल बनाने का,
हम हैं जिंदगी, हम हैं हर खुशी.
Based on the results of this well, we'll be making a development plan for this area. Say, similar wells we have drilled in Parbatpur and Talgaria, and based on the result of exploratory wells, we are now going to, drill 14 very high technology wells at the very high cost of 550 crores rupees.
Yeah, Mr. Sachin, what this air drilling is all about, and why you are performing such a new kind of concept?
See, I'll say new concept. Of course, this is very new for India. This is the second time we are doing. But of course, internationally, this type of operations has been done. This air drilling, it has been seen that it's really, really very effective. I hope within 24 hours they can finish this operation. It's really very cost saving and it's very effective. That's how this technology is very important for us, because we intend to really drill very large number of wells in this area. I think next 5 years, something like 200 wells we will be drilling. Apart from cost saving, the time saving is more important. Let me explain you this entire process which can be simulated in a very simple way. The cutting tool is the pencil sharpener itself. Okay, that is stationary. Normally we hold with the firm hand, and then there is a pencil itself which we rotate. So with the right hand or left hand we rotate the pencil. As a result, there is a rotation generated. And the third thing is pencil, which is being virtually sharpened. So if I tell you here how it is simulated, here the cutting tool is rotating. There is a cutting tool, and then there is a rotation. It has to be rotated, and also it has to be little bit pushed, what we call technically as a feed, so that the cutting process takes place. So this is the heart of drilling.
The process of air drilling first starts by making a hole up to the depth of 5 meters in the precise point of the proposed well site. A big hammer with a spherical head drills through the hole downwards by cutting, drilling and moving out hard rock like earth's surface up to another 25 meters. And then a plastic pipe is lowered down to protect the side walls of the hole to fall down. Then again, the downwards drilling process starts till it reaches the proposed depth. An enormous amount of air pressure is required to achieve the desired thrust with this penetration.
I can see there's two machines there. Yeah. What is the purpose of having two machines?
Virtually, I can say they both are used for air drilling. The machine on our left right now is in use. It has more drilling depth capacity, whereas in the machine on our right side is being used to supply additional air so that it can drill further deep.
So it requires that more thirst to enter the crust.
Yes, exactly right. As a result of that, I mean, it can drill much deeper. When drilling is started and at the surface, the hole has to be enlarged. So the very loose formations using this cutting tool can be cut. We are looking at the one air hammer, what we call. It is having a cutting tool at the bottom of this. This portion, there is a arrangement of vibration. So this cutting tool is being vibrated, at the same time it is rotating. You see the tips over there? These are the industrial diamonds, and there is a holes over there. These holes are for air circulation, so that whatever formation in powder or chips form is generated, it's removed. Air performs very important operations in this case, I mean.
So how much you are planning to penetrate? How deep?
Well, very tentatively, we have planned to cover entire about 250 meters of top formations, which are very hard rocks. It's like a stone, and that is where this air drilling is very effective.
हमें है उजाला अंधियारा मिटाने का, हमें है हौसला नई उमंग बनाने का, हमें है एक जोश हर मंजिल पाने का, हमें है एक जज्बा हर जिंदगी सजाने का,
हमें है जोश हर मंजिल को पाने का, हमें है एक वादा एक सुनहरा कल बनाने का,
हम हैं जिंदगी, हम हैं हर खुशी.
Did you face any difficulties during the entire process?
Yes, number of difficulties that we have faced. To start with, I can say that, well, there was at times very poor visibility due to a lot of dust coming out of the hole. This dust is generated during the process of drilling, and it is thrown out of using air pressure. So, but this problem was not constant. It was at times when a lot of cuttings were coming out. Another thing we faced that, well, during the process of drilling, we passed through various formations, and number of water zones we have passed through. In that process, a lot of water was also coming along with the cuttings. So because of that, there was no proper cleaning of the hole. So to remove the cuttings was another area of challenge, and we have to consume more time flushing it out. And then operationally, at some point of time, once we got virtually stuck, the tool was neither going down nor coming up. But anyway, after working for some time, we released it, and now the operations were back to normal. And so far, I can say that, well, this is a sort of milestone we have achieved. With this, I can say that, well, this process of air drilling can be done indigenously within India with our own people, and we have not to be dependent on any foreign expertise as far as these operations are concerned.
Coal bed methane can be used as an alternate source of energy that is environmentally more acceptable than mining and combustion of coal. It It can partly replace coal as a fossil energy source, and it sometimes occurs where other conventional resources of oil and gas are not present. CBM can be effectively used in various industries like power, steel, fertilizers, and as CNG, as well as for domestic usages. It is much more important to the eastern part of the country, as there are no proven oil and gas resources so far. Whereas there are vast coal reserves containing large quantity of CBM. In this process, we can ensure a safer and clean environment for our future generation. And exactly that is what this lonely veteran warrior is dreaming of.